In this video, you're going to learn how to find the circumcenter, the orthocenter, and the centroid algebraically. And we're going to go through two examples together. So let's dive in. We'll talk about the formulas. We'll talk about some techniques for finding all three of these. And for the first problem, they're giving us these three vertices of a triangle. And I've taken the liberty here of drawing it on the right so that we can kind of visualize what we're dealing with here. Now, the first thing we're going to do is we're going to find the centroid. And the centroid is where the three medians intersect or cross. It's called a point of concurrency because it's where the three medians are going to intersect. It's that common point. And when you think of a median, what you're thinking of, it's from the vertex to the midpoint of the opposite side. That's what a median is. You can think median like middle. So from the vertex to the middle of the opposite side. So you would really have 1, 2, 3 of these medians, and we're going to find that point where they cross. Now there's a nice easy formula that you can utilize, and what it is, it's the average of the x coordinates and the average of the y coordinates. So you're going to add them up and divide by 3. So let's go ahead and do that. So for the centroid, let's just do -1 plus 4 plus 1 divided by 3, and we'll also do the same thing for the y's. So we've got 2 plus 0 plus 6 divided by 3. And this is coming out to, let's see, this is 0, so this comes out to 4/3, comma, 8/3. Okay, that's our centroid. Okay, now let's move on to the circumcenter. Now the circumcenter is where the three perpendicular bisectors cross. So when you think of a perpendicular bisector, what you're doing is you're bisecting or cutting the segment in half, but you're also drawing a line that's perpendicular or at a right angle to that side. And you're going to go ahead and do that for, you can do it for all three, but really you just need to do it for 2 of them because where the 2 intersect, the third one would intersect at that same point as well. So we're just going to do it with 2 of the perpendicular bisectors. So maybe let's start with finding the slope of AC. Okay, so the slope of AC, let's write that down here, m for slope. AC, we use the formula y2 minus y1 over x2 minus x1. So in this case, it would be 6 minus 2, which is 4, over 1 minus -1, which is 2. 4 divided by 2 is 2. Now what we want to do is we want to find not the slope, but the perpendicular slope. And so that requires the opposite reciprocal. So remember, the reciprocal, we flip it over, and then the opposite, we change the sign. So I'm just going to write the slope of AC perpendicular. That's going to be -1/2. Okay, now we need to find the midpoint. And the midpoint, it's the average of the x's, average of the y's. So you just add them up and divide by 2. So let's go ahead and do that. So we've got the midpoint, capital M, of AC is equal to -1 plus 1, which is 0, divided by 2. That's going to be 0. And 2 plus 6 is 8 divided by 2, which is going to be 4. Okay, so you can see that's going to be right in the middle here. Okay, now we can write an equation of that perpendicular bisector. And the way that we do that is we're going to use the perpendicular slope and this point. And you can either use the y equals mx plus b form of the equation of a line or the point slope form. So I'll just do the slope intercept here. Since we know the y-intercept is 4, and we know the slope is -1/2, there is the equation of our perpendicular bisector of AC. Now let's find the perpendicular bisector of, let's do AB. So what's the slope of AB? Well, let's see. So slope of AB is equal to y2 minus y1. So 0 minus 2 is -2 over x2 minus x1. 4 minus -1 is 5. But we want the perpendicular slope, so we have to take the opposite reciprocal. That's going to be a positive 5 over 2. Now we need to find the midpoint of AB. So remember the midpoint formula. We're going to average the x's and average the y's. So 4 plus -1 is 3 divided by 2. And 0 plus 2 divided by 2, which is 1. Now we're going to use the perpendicular slope and the midpoint, and that's going to be our other equation of our perpendicular bisector of AB. So let's go ahead and use the point slope form. Now remember, point slope form is y minus y1 equals m times x minus x1. So we're going to do y minus the y coordinate of the midpoint equals the perpendicular slope times x minus the x-coordinate of the midpoint. Okay, I'm just going to rewrite this and distribute. So we've got 5/2 x minus 15/4. I'm going to add the 1 to the other side, which is like adding 4/4. So that comes out to y equals 5/2 x minus 11/4. Okay, so not great numbers on this problem, but I wanted to make it more realistic, like something you might encounter. Now we're going to find out where these two perpendicular bisectors cross, that point of concurrency. And so what we can do is we can do the substitution or the elimination method. Now for this one, I think I'm just going to do the substitution method. So if y equals negative 1/2 x plus 4, I'm going to put it in for y right here. So let's go ahead and do that up here. We've got negative 1/2 x plus 4 equals 5/2 x minus 11/4. Okay, now what I'm going to do is I'm going to clear the denominators by multiplying through by 4. So if I multiply this whole equation, left and right sides, by 4, it's still, equivalent. It's just going to be in a different form. So 4 times negative 1/2 is negative 2x plus 16 equals 20 over 2, which is 10x minus 11. Let's subtract 10x from both sides. Let's subtract 16 from both sides. Let's divide by negative 12. That comes out to 27/12, which reduces down to 9/4. Okay, now if we take 9/4 and we put it back in for x either here or here, we can find the y-coordinate. I'll just put it into this one. So it's going to be y equals negative 1/2 times 9/4 plus 4. Okay, so that gives us negative 9/8 plus 32/8, if we get a common denominator, and that comes out to, let's see, 23/8, no, 23/8, 23/8. Okay, and so now our point of concurrency where our circumcenter is going to be at 9/4, comma, 23/8. Not a great number, but that's where it is. Okay, and then lastly, let's talk about how to find the orthocenter. Now that's where the three altitudes cross. Now when you think of the altitude, what you're doing is you're going from the vertex perpendicular to the opposite side. Okay, so we're going to find out where those three altitudes cross, but we only really need to find the equations of 2 of the altitudes. We'll find out where those intersect. The third one would cross at the same point. So let's do that. So now let's see. So we already know the slope of AB is negative 2/5, right? So that means that we're going to find the perpendicular slope, which is going to be 5/2, and we're going to use the point that's across from AB, which is C. So I'm going to use the slope of 5/2 and this point 1 comma 6 to write the equation of our altitude. So that's going to be, let's see, it's going to be y minus 6 equals 5/2 times x minus 1. Okay, let's rewrite this a little bit. Let's distribute. We've got 5/2 x minus 5/2. Let's add the 6 to the other side. That's 12/2. And so now we get y equals 5/2 x plus 7/2. Okay, now that's the equation of this altitude here. Let's go ahead and find the altitude from B to AC. Now we already know the slope of AC, it's 2. The perpendicular slope is going to be negative 1/2. And we know it's going to go through this point 4 comma 0. So let's write that equation. We're running out of space. So let's see, we've got a y minus 0 equals negative 1/2 x minus 4. Let's distribute. We get y equals negative 1/2 x plus 2. And y minus 0 is just a y. So, okay, so now we have these two equations of our two altitudes there. We can find out where these intersect. So what we can do is, let's do the substitution method again. Let's put negative 1/2 x plus 2 in here. And let's see where I can put that. Let me erase the board and we'll come back and I'll show you. Okay, so now setting these two equations of our altitudes equal to one another by doing a substitution, we can solve for the point of intersection, that point of concurrency. So that's what we have here. Negative 1/2 x plus 2 equals 5/2 x plus 7/2. Let's go ahead and multiply through by 2, both the left and right sides of the equation, and keep it balanced to clear the denominators. So if we do that, we get negative x plus 4 equals 5x plus 7. A little bit easier to work with, right? So let's subtract 5x from both sides. Let's subtract 4 from both sides. So that comes out to negative 6x equals 3. And if we divide both sides by negative 6, x is equal to negative 1/2. Okay, now to find the y-coordinate, we're going to put that back into either one of these equations. I'll just do this bottom one here. So we get y equals negative 1/2 times negative 1/2 plus 2. So that's positive 1/4 plus 2, which 2 is like 8/4 plus 1/4 is 9/4. So our point here of intersection, which is our orthocenter, is negative 1/2 comma 9/4. And you got it. So let's take a look at another example. And before we do that, I'm going to draw some diagrams so we can help visualize a little bit better what the altitude looks like, whether it's an acute triangle, a right triangle, an obtuse triangle. Same thing with the circumcenter and the centroid. So let's look at that next. Before we go on to example number 2, which I'm going to hope you're going to practice this one on your own, and we'll go through it together so you can get some experience. But let's kind of get a picture, like a picture's worth 1,000 words, right, as the saying goes. So circumcenter, remember, circumcenter is where the 3 perpendicular bisectors cross. So what exactly does that look like? Well, when you think of a perpendicular bisector means it goes through the midpoint, it bisects it or cuts it in half. Perpendicular means that, it's like at a right angle. Now, you want to make sure that you don't confuse like the altitude and the perpendicular bisector. When you're drawing a perpendicular, it doesn't have to necessarily go through that opposite vertex. Okay, so that's an important thing to recognize. Now over here, if I find the midpoint, see of this side, and I draw a perpendicular, okay, and then if I do the same thing for this side, I find the midpoint, and draw a perpendicular, see how they're all crossing at this one point. That's called the circumcenter. Now notice that this triangle is an acute triangle. All the angles are less than 90. When it's an acute triangle, that circumcenter is going to be inside of the triangle. So that's important to recognize. Now, what exactly does that mean, a circumcenter? Well, it means that if we treat this point as if it is the center of a circle, you can circumscribe or draw a circle around that triangle such that the vertices lie right on the circle. So basically what you have is you have the radius to each of these vertices is going to be congruent. Now, if it's a right triangle like this, where you have a 90-degree angle, when you go to find the perpendicular bisector, let's go ahead and draw it. So perpendicular, okay, and it cuts that side in half. Perpendicular, and it cuts this side in half. And again, you can do the third side as well, but the key thing is that realize that this point is right on the hypotenuse. So if it's a right triangle, your circumcenter is going to be right on the hypotenuse, so right on the triangle. And again, what you're doing is that's the center of a circle, and you're circumscribing or drawing the circle about or around the triangle such that the vertices lie right on that circle. Okay. And then lastly, if you have a obtuse triangle and you're finding the circumcenter, you find that midpoint. Okay, draw a perpendicular, okay, right angle, find the midpoint, draw a perpendicular, okay, so 90 degrees. Notice that the point of concurrency is outside of the circle, that circumcenter. So now when you go to circumscribe or draw that circle around the triangle, it's going to look something like that. So notice, acute triangle, circumcenter is inside. Right triangle, circumcenter is on the triangle, specifically right on the hypotenuse. Obtuse triangle, it's outside the triangle. Okay, so if it's obtuse. Now let's look at the orthocenter. Orthocenter, remember, is where the 3 altitudes intersect or cross. Again, you only have to draw 2 of them, but if you want to double check your work, you can do a third. But in the altitude, you go from the vertex perpendicular to the opposite side. It doesn't necessarily bisect or cut that opposite side in half, right? Think of a triangle as like a mountain. If you climb a mountain, okay, and somebody says, how high above the ground are you? You would measure straight down to the ground. You wouldn't measure on an angle or, like that. You go perpendicular to the opposite side. Same thing over here. If you rotate this triangle, say this is the top of the mountain, you go perpendicular to that opposite side. Same thing here, perpendicular to that opposite side. You can see they're all crossing right there inside the triangle. Notice it's an acute triangle, so that orthocenter is on the inside. Now, if it's a right triangle, what happens? Again, here's our mountain analogy, right? You would measure perpendicular to the opposite side, so there's our altitude. If I rotate this triangle, make this the top of the mountain, okay, and you're measuring perpendicular to the opposite side, okay, and if I make this is the top of the mountain, and then you go perpendicular to the opposite side, you can see that they're all crossing right here at this, where the right angle is. So acute, it's inside the orthocenter. Right, it's on, okay, the triangle. And now over here, obtuse, what do you think is going to happen? Well, when you have an obtuse triangle, again, if we like our mountain analogy, altitude is kind of like the height, right? You have to actually extend this side in an obtuse triangle. So that's your altitude right there, okay? So you can draw a line. Same thing over here. We can extend this, draw a perpendicular. That's your altitude here, okay? And you can see that they're going to cross outside of the triangle. So it's very similar to circumcenter, but it's a different thing that we're finding, you know, with this circumcenter versus the orthocenter. But acute inside, right on, obtuse, it's going to be outside. Okay, lastly, centroid. Centroid, it's like the center of mass. So if you were to cut out this triangle, okay, if I cut this out of my whiteboard, I have a hole in my whiteboard, but I'd show you right at the centroid, we could balance it right at that point, okay? And that's basically the center of mass or center of gravity. But what you're doing is you're going from the vertex to the midpoint of the opposite side. So there's a median, right, to the middle. Okay, let's find the midpoint over here. Go from the vertex to the middle of that opposite side. Same thing over here. Find the midpoint and go from the vertex to the middle of the opposite side. Notice the centroid. It's always going to be inside the triangle. Remember, because it's a balance point. It's a center of gravity. It's not going to be on the outside or on. Now, let's just go ahead and do it over here. So here's the midpoint from the vertex to the middle of the opposite side. Here's the midpoint from the vertex to the middle of the opposite side. Here's the midpoint from the vertex to the middle of the opposite side. See how they all cross, again, inside the triangle. Obtuse triangle, same thing. Midpoint, vertex to the middle of the opposite side. Midpoint from the vertex to the middle of the opposite side. Midpoint, okay, from the vertex to the middle of the opposite side. See how they're all crossing at that point of concurrency, and it's always on the inside. Okay, let's look at example number 2. Okay, see if you can do example number 2. First thing I'm going to do is I'm going to start off with the centroid. So remember the centroid, it's that center of mass. It's where the 3 medians cross. And we have a handy formula to find that point by averaging the x's and averaging the y's. So to do that, let's just go ahead and add the x's together. So 0 plus 2 plus negative 2 divided by 3. And negative 6 plus negative 2 plus 6 divided by 3. Sometimes people make a mistake. They divide by 2 because they're so used to thinking about the midpoint. But this is like you're averaging 3 points. So you're adding the x's together and dividing by 3, and you're adding the y's together and dividing by 3. So this comes out to, let's see, 0 over 3, which is 0, and negative 2 over 3. Okay, so that's your centroid. So that one's simple. Okay, let's go to the circumcenter now, the 3 perpendicular bisectors. Again, we only have to find 2, and then we're going to write the equations and find out where those 2 lines intersect. So which side should we do? How about we find the slope of AC? Okay, so AC, again, remember we use the letter lowercase m for slope. AC is equal to y2 minus y1 over x2 minus x1. So we'll do 6 minus negative 6, which is 12, over negative 2 minus 0, which is negative 2. That comes out to a slope of negative 6. Now we're going to look at the perpendicular slope, which is the opposite reciprocal. So this would be a positive 1/6. Now we need to find the midpoint of AC. And to do that, we average the x's and we average the y's. So that would be 0 plus negative 2 is negative 2 divided by 2. And 6 plus negative 6, which is 0, divided by 2, that comes out to negative 1 comma 0. Okay, so now we have the midpoint and we have the perpendicular slope. So here's our midpoint, perpendicular. So that's going to be, let's do y minus y1 equals the slope times x minus x1. But when you subtract a negative, it's like adding the opposite. Y minus 0 is y. Distribute the 1/6, we get 1/6 x plus 1/6. Okay, that's the equation of one of our perpendicular bisectors. Let's go ahead and find another one. How about we do AB here? Okay, so AB, let's go ahead and find the slope. So let's do that right here. So slope of AB is equal to y2 minus y1, so negative 2 minus negative 6, which is 4, over 2 minus 0, which is 2, so that's the slope of 2. Now if we find the perpendicular slope, that's going to be the opposite reciprocal, so that's going to be negative 1/2. And now if we find the midpoint of AB, that's the average of the x's and average of the y. So 2 plus 0 divided by 2 is going to be 1. And negative 2 plus negative 6 is negative 8 divided by 2 is negative 4. Okay, so now we're going to use the perpendicular slope and the midpoint to find the equation of our perpendicular bisector. So that's going to be, let's write it right here. So we have y minus the y coordinate equals the slope, negative 1/2, times x minus the x coordinate. Okay, so when you subtract, it's like adding the opposite. So we have y plus 4 equals negative 1/2 x plus 1/2. Let's subtract 4 from both sides. 4 is like 8 over 2. So if we subtract 8 over 2, this is going to be negative 7 over 2. Now we just have to find the point of intersection of these two perpendicular bisectors. Let's do the substitution method. Let's put this in place of y. Now you might be saying, Mario, I didn't use those two sides that you're using. It doesn't matter. You'll get the same answer. Okay, so as long as you find two of the perpendicular bisectors, you'll find out where they cross. You're going to see you're going to get the same answer. If you don't, you might have made a little bit of an arithmetic error, which it's easy to do. You can see all the calculations. Let's clear the denominators. Let's multiply everything by 6. So that's going to give us x plus 1 equals negative 3 minus 21. Negative 3x. I lost my x here. Okay, thanks for pointing that out. Okay, so now, let's see, add the 3x, that's 4x. Subtract 1, that's negative 22. Divide by 4, that's negative 22 fourths, which is a negative 11 halves. Okay, so that's interesting. Let's put it back into either equation. I'll just do this one here. So that's going to be y equals a negative 1/2 times a negative 11 halves minus 7 halves. That comes out to 11 fourths minus 14 fourths, which is negative 3 fourths. So our point is, what is it? Our x value is a negative 11 halves, comma, negative 3 fourths. That is our circumcenter. Okay, and let's look at this for a minute. So this is negative 5.5. 1, 2, 3, 4, 5.5, somewhere over here, down 3 fourths. The point's right here. Now, why is it outside? That's because this is an obtuse triangle, so the circumcenter is going to be outside of the triangle, like we discussed earlier. Okay, now, orthocenter, right? So the 3 altitudes. We're just going to do 2 of them. Now, I like to kind of make the work a little bit easier, so I'm going to kind of use some of the information we found here already. Like we found the slope of AC, which was negative 6. Let's use the perpendicular slope, 1/6. Okay, so the perpendicular to AC would be 1/6, and it goes to the opposite vertex, which is 2, negative 2. So let's write the equation of the altitude. It's going to be y minus the y coordinate, which is negative 2, equals the slope, which is 1/6 times x minus the x coordinate. Let's add the opposite. So we have y plus 2 equals 1/6 x minus 2/6. Subtract 2 from both sides. 2 is like 12/6, so we subtract 12/6, that's going to be negative 14/6, which is negative 7/3. Okay, so you can see the calculations can get a little tricky with the fractions. Okay, now let's use some more information that we did previously. How about we do the slope of AB, which is right here, and the perpendicular slope, which is negative 1/2. So we're going to go from the point opposite, okay, AB, and we're going to draw a perpendicular, okay? So we've got negative 1/2, and we've got negative 2/6. So let's write that equation. So y minus y1 equals negative 1/2 times x minus x1. Okay, so now we get, let's see, y minus 6 equals negative 1/2 x minus 1. Oh, that worked out nice. Add 6 to both sides. We get negative 1/2 x plus 5. Okay, so now we're going to use these two equations here to find where they intersect. That's going to be our orthocenter. Again, I'll just do substitution. I'll put this in place of y here. So we get negative 1/2 x plus 5 is equal to 1/6 x minus 7/3. Let's multiply through by the common denominator, which is 6. Both sides, keep the equation balanced. That's going to give us negative 3x plus 30 equals x minus 14. Subtract x from both sides, that's negative 4x. Subtract 30 from both sides, that's negative 44. Oh, this is working out nice. Divided by negative 4, x is 11. We can put that back in to either equation. I'll just do this one. So we get y equals negative 1/2 times 11 plus 5. So that comes out to negative 11 halves plus 5 is 10 halves. That comes out to negative 1/2. Okay, so we've got it. It's going to be 11 comma negative 1/2 is the point of our orthocenter. So great job if you're able to follow these two examples. If you want more practice, which I definitely recommend, I'm going to send you over to a video right there. I also want to mention that if you like the way I teach geometry, become a member. And on my additional videos member level, I've got my geometry course on there, so you can get access to my whole geometry course, and we can go through that together. So I'll see you over there.